Everybody. So in this video, we're going to look at taking moments when an object, such as a beam or a ladder, is on a point of tilting. So when an object, such as a beam or a ladder, is at the point of tilting, it implies that the object is pivoting or lifting off from all but one point of contact. The moment of a force causing this is just on the brink of exceeding the stabilizing moments that have kept the object in place. And at this point of tilting, the normal reaction force at the point where the object is about to lift becomes zero, and all the weight of a vertical reaction acts on the remaining point of contact. So as we progress through the video, we're going to look at 3 examples which demonstrate this. Okay, so in example 1, we're told that a non-uniform rod AB of mass m kilograms rests horizontally on supports C and D. And because it's non-uniform, this means that the weight of a rod will not be acting in the center. So we're told this mg here may not be the center of this rod. And when an object of mass 18 kilograms is placed at point B, which is this mass here, the plank is in equilibrium and is on the point of tilting about D. So this mass is going to tilt this rod about D in this direction. And we've been asked to find the mass of a rod and the magnitude of a reaction at D. Okay, so because it's going to be tilting at D, we're going to look at taking moments at this point. So if we begin by looking at the clockwise moments from D, well, this will be the moments going in this direction. So we're looking at this force of 20G newtons multiplied by the distance of 1.2 meters. So this will give us a moment of 24G Newton meters. And if we look at the anti-clockwise moments from D, we'll think about this mg. It will rotate anti-clockwise. This will have a force of mg newtons multiplied by the distance from D of 0.6 meters. So this will give us 0.6 mg Newton meters in the anti-clockwise sense. And because we're told the plank is in equilibrium and on the point of tilting, so it hasn't quite tilted, but it's on the point of it, then the clockwise moment will be equal to the anti-clockwise moment. So 24G will equal 0.6 mg. We can divide both sides by g, so these will cancel, and then to find m, we'll divide both sides by 0.6. So the mass will be 24 divided by 0.6, and that will be 40 kilograms. Okay? And to resolve vertically, well, if we think about the vertical normal reaction from C, we'll call this RC, and the normal reaction from D, we'll call this RD. Well, then resolving this vertically, RC plus RD will equal the downward force, which is the mass plus the 20G. So this is 60G. But we're told that when this mass is applied, the rod is on the point of tilting, which means all the normal reaction from C becomes zero. So this becomes zero. So therefore, RD will equal 60G, which is 60 times 9.8, 588 newtons. Okay? Let's move on to example 2. Okay, so in example 2, we're told that the diagram shows a uniform rod AB of length 9 meters, so 9 meters from here to here, and mass 30 kilograms. Because it's uniform, this mass will act in the center of the rod. And it rests on 2 supports at points C and D is 2 meters from point B, which is here. A student of mass 60 kilograms starts at point D, so starts here, and walks towards B in this direction. How far has she gone when the plank starts to tilt? Okay, so because the student has started here, we'll have the normal reaction at D. We'll call this RD. And the student travelled in this direction, but we don't know how far, so we'll say she's travelled X meters to here. And then because it's going to rotate or tilt at point D, this is where we'll take the moments from. So taking moments from D, we know the clockwise moments from D will be the student of mass 60 kilograms, so we'll have a downward force of 60 newtons multiplied by a distance of x meters, and this will give us 60 xg newton meters. The anti-clockwise moments, well, we're told that it's uniform with a mass of 30, so we'll have 30g acting in the center of the rod, and the rod is length 9 meters, so this will be 4.5 from here to B. We know this length is 2, so this will be 2.5 meters. So we'll have the force of 30g multiplied by the distance of 2.5, which will give us a moment of 75g newton meters, acting in the anti-clockwise sense. Because it's on the point of tilting, then these two moments will be equal. So 60xg will be equal to 75g. We can cancel out the g's, so 60x will equal 75. So x will be equal to 1.25 meters. And that means that she's travelled 1.25 meters from D. So this will be the final solution. Okay? Let's try one more example. Okay, so in example 3, we're told that a uniform rod, AB, of length 8 meters hangs in equilibrium, we'll underline that, in a horizontal position from two strings attached to the rods at points C and D, which are here and here, where A to C is 3 meters and D to B is 2 meters. And when a weight of 400 newtons is placed on a rod at A, the rod is on a point of tilting. And then the weight is removed from point A and a different weight, W newtons, is placed at B. So that is taken off here and a different weight is placed on here. Given the plank is on the point of tilting, work out W. Okay, so the first thing we'll do is we'll think about what's happening here. When a weight of 400 newtons is placed on the rod at A, so we'll have this 400 newtons acting downwards. And because it's not given in kilograms, we don't need to think about the gravity because that's included. So that'd be 400 newtons. And we can use this 400 newtons to work out the force of the rod acting downwards here. So this will be the weight, which is, we'll call M. Okay, so if we look at taking moments from C, we'll look at the clockwise moments. This will be the downward force of M newtons. We don't need to think about gravity because this is the newtons. Multiplied by the distance, where we're told it's uniform. So we know from A to M will be 4. We know A to C is 3, so this will be 1. So we'll just have M Newton meters. The anti-clockwise moment will be this 400 newtons multiplied by 3. So this will be 1200 Newton meters. And we know when it's placed at A, it is in equilibrium. So the two moments will be equal. M will then equal 1200 Newton meters. So this is the weight of a rod, 1200 newtons. If we move on to the next part, the weight is then removed from A and a different weight W is placed at B. So if we take this off and get rid of this, and now we can put it at B with a downward force of W newtons. And when W is applied at B, it's on a point of tilting, which means we've got no normal reaction at C, it's all at D. So we'll take the moments from D. The clockwise moments will be the distance 2 times the weight W, so 2W. The anti-clockwise moments from D will be the 1200 newtons multiplied by this length. And we know this is 4, so this will be 2. So this will be 2 lots of 1200 Newton meters. And because it's on the point of tilting, we know these moments will be equal. So 2W will equal 2,400. So the weight W will be 1,200 newtons. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again and take care.